A radar signal from Earth bounces off a comet and returns to Earth. The round trip takes 500 seconds. Okay, how far away from Earth? Let's just concentrate on part one first. Part A, I mean, how far away from is this comet from Earth? All right, so we'll concentrate on that, and we'll do the angular size a little bit later. All right, so the basic equation here that we're going to use is you know the speed of light. Okay, so we're also given the speed of light in right here in kilometers per second. Oops, let me switch that. Sorry. So in kilometers per second, and hold on. Here, let me pause this. The equation that we're going to use is the speed of light, c, is equal to the distance divided by the time. Now, the thing about this is we got to rearrange this equation and solve for d. So I'm going to do that. I'm going to do that over here. All right, so d is equal to, so you just bring the t over to the other side, and it's equal to t, the time, times the speed of light. All right, so that's our basic equation that we're going to use, and I'll put a box around that. And the other thing is it says that this is the round trip time. All right, so if we draw a little picture, let's say that this is the Earth, there's the Earth, and the comet is like way up here, and a radar signal is going to go out. All right, so that's simulating the radar signal. It hits this thing. Some of it keeps going, but some of it returns. Right, some of the radar signal comes back, and that round trip time, the time to go to the comet and to come back, is 500 seconds. So the distance, the distance d here. If I want to know what d is, right, the distance from Earth to the comet, then I'm only interested in half of the time, right? So the round trip time is 500 seconds, right? 500 seconds, but the time it just takes to get to the comet is just 500 seconds divided by 2. Right? That's of course seconds. All right, and so of course the time here is 250 seconds. All right, so now that we know that, we're going to plug it into this equation, and solve for d. Right, so d is equal to 250, right, seconds. Now the units have to cancel, right? So the time is in the units of seconds. The speed of light is, we're going to use this number right here. So the speed of light is commonly in units of meters per second. So that's 3 times 10 to the 8th meters per second. You might see it like that sometimes. And in fact, in some equations, it has to be that. In this particular equation, we're going to want it to be in kilometers because we want to know how far away from the Earth this comet is in kilometers. All right, so we plug in the speed of light is 3 times 10 to the 5th. Right, that's supposed to be a 5. Sorry, and that's of course kilometers per second. And of course, this seconds cancels this seconds, and that just leaves us with kilometers. All right, so we just need a scientific calculator. So let me get that. All right, so with this calculator, and yours might be a little different. This is how. Remember, when you type in 3 times 10 to the 5th, you're never hitting times. You're never hitting 10. All right, so you got to know how to do this with your calculator. Usually, it's an EE button or an EXP button. All right, with this one, it's the EXP button. So here we go. 3 EXP to the 5th. All right, so that literally means 3 times 10 to the 5th. Let me mention something as well. Sometimes, just to let you know, sometimes I'll write that in this manner. Instead of saying 3 times 10 to the 5th, I'll write 3E5. And that means the same thing. Okay, so just be aware of that. All right, let's complete this calculation. So 3 times 10 to the fifth, that's what this is in the calculator. Again, you're never hitting times, you're never hitting 10. You have to have a scientific calculator to do this, right? This is, of course, a college level science course, so make sure you have access to a scientific calculator. All right, so anyhow, so times 250. All right, so now notice this calculator did not put it in scientific notation. I'm going to put it in scientific notation here. So the answer D turns out to be 75 million. All right, so 75 million. So here, let me do the answer right here. So this is 75 million. All right. But so here I'll put the zeros just for the heck of it. Million kilometers. All right, so that's fine. But it's more appropriate to put the answer in scientific notation. All right, and it's important to understand that with Blackboard you want to use the E button for the times 10 part. So here I'm gonna traditionally we write this as so here's the answer. D is equal to 7.5. And so there's 6 zeros, and then I moved it one more place, right? So the decimal place is implied right here. There's 3, there's another 3, and there's one more. So that's going to be 7.5 times 10 to the 7th kilometers. All right, so that's the answer to part A. All right, so let's do part B. Pause this. For the second part, it says that the angular size of the comet as observed from Earth is, and so the thing, this part right here, that the way that reads is 0.07 arc minutes and 0.53 arc seconds. All right, so and I've written over here, 1 degree is 60 arc minutes. Like if you took a degree, like if you take like a protractor and you looked at 1 degree, that's just a tiny little angle. But if you broke that angle into 60 equal parts, like 60 little pi wedges, that one of those would be called an arc minute. All right. So and then in astronomy you can go much further than that. You can take 1 arc minute and break it into what are called arc seconds. All right. So there's 60 arc seconds in 1 arc minute, and then of course there's 60 arc minutes in 1 degree. All right. So all right, so let's convert this, right? So we're going to convert here. So I'm just going to do it, and it should make sense. All right, so we know that it's 0.07. Right, a single hash mark means that it's arc minutes, right? And we know that there are 60 arc minutes in 1 degree. We need these to be in degrees. We need alpha to be in degrees. All right, so plus 0.0. Oh, sorry, it's not 0.0 here. It's 0.5, 0.53. Oh, jeez, I didn't get the right size. Okay, here we go. Wrong thing. Sorry. Which one did I use? Yeah, I think this is right. 0.53. Oh, come on. 0.53. That's a decimal point. That's just consider that the decimal point right there. And so to convert that into degrees, you just have to convert. So it's going to be 60 times 60, right? So it's going to be 60. Because see, there's 60 arc minutes in 1 degree, but then there's 60 arc seconds. This is in arc seconds, so you just say 60, and then you say 60 again, right? 60. All right, and so I know that doesn't look very nice, but so alpha. This is all we're doing is we're turning alpha into degrees. All right, so it's going to be 0.07, right, divided by 60, because that changes it into degrees, plus a little bit more, plus 0.53 divided by 60 squared. All right, so that's just a simple way of doing that real quickly. All right, and so let's see what this angle is. All right, so we'll do this in this calculator here. All right, so we have 0.07 divided by 60. All right, so this is converting the arc minutes. So this part, the 0.07 part, we just did that, and then we have to add to that 0.53, and this is just a small difference, divided by 60 squared. All right, so 60 squared. So hopefully you know where the squared button is on your calculator. All right, so see, it's not that much different than it was before. So alpha is now 0.0013. So here, I'm just going to write that down. All right, so that's what alpha is in degrees. 0.0013, and that's now in degrees. All right, so this conversion, that you always do it this way, and if the angle is in degrees and it's in arc minutes and arc seconds. Sometimes they're just in arc minutes or just in arc seconds, and you just use these conversions. All right, that's all that is. All right, so we're going to take this 0.003, 0.0013, and we're going to use it in our we've got to figure out the size of the comet, the actual size of the comet. All right, and so that's so we have an equation for that. It's script L is equal to. All right, so here, I'm going to erase some of this and write this a little bit bigger. All right, so this equation is given to us on our equation sheet. You can just take a look at it. So here's what this says. The size, so that's what the script L is. The size of an object is equal to pi over 180 times the distance to the object divided by the angular size of the object. And notice in the calculator, we just figured out what the angular size is. It has to be in degrees. All right. In the problem, it was originally given to us in a combination of arc minutes and arc seconds. All right. So and we converted that to degrees. All right. So here, now we're going to put the numbers, and we already found what D is, right? Remember, D was that 7.5 times 10 to the 7th. All right, so it's going to be 180. It's a pi over 180. All right, so those are just normal numbers, times 7.5 times 10. I'm just going to use the E here. It's easier. Times 10 to the 7th kilometers, right? And then times alpha, which remember we just calculated it. Let me show it on the calculator one more time. I'm just gonna round it. So it's 0.0013. Right. So in degrees it would be 0.0013 degrees, right? All right. So I put everything in the calculator. I get 1,719. And if I round it one place past the decimal, it would be 1,719.9, and it's kilometers. The units of the distance is the same units as the length, the actual size of the comet. All right, so that's our first problem.